All right, today there was a homework assignment that's supposed to be due this evening. I'll give you an extra 24 hours because I'm going to demo how to do it. There's actually no program that you have to do. What you have to do is you have to install a couple of projects and do a little experiment. And I'm going to demo all that stuff right now to show you how to do it. What we're going to do now is we're going to introduce this phenomenon that's possible in C and C++. And the way we're going to illustrate this is with a classic C++ array. And I don't want to spend a whole lot of time going through line-by-line detail here, but there is a function called readStream and another function called WriteStream that is in this project. It's called Array Classic. The name of the project is called Array Classic. And basically what readStream does is it takes information from an input stream and it reads it into an array. And WriteStream takes information from the array and it streams it to the output device. Okay? And the key thing here is that there is this concept of capacity, and we're going to abbreviate that CAP. So CAP means the capacity of the array. So here in figure 2.9 is the main program, and let's take a look at what this main program does. What it does is it prompts the user for a file of numbers. All right? And it says enter array capacity, and then the user is going to enter the array capacity, and then it sets up this an array of doubles. So it's double star ARR, and that's gets new double cap. Okay, so this allocates the array from the heap. We're doing a new array, and then this IFS is the input file stream variable. And I don't want to go into the details here. You can look at the code in the project and see how all that stuff works. It's just grubby file stuff that we don't have to worry about. And then what it does is it reads the numbers from a file into the array, and then it just prints them out. All right, and then it deletes the array, and then it returns exit success. Okay, and here in figure 2.9 also are the details of how readStream works and how WriteStream works. And I'll demo this for you. So let's demo Array Classic. Okay, so here's our demo. And we have our DP4S distribution here, and here's all the projects. And what we're going to do this time is we're going to take a look at Array Classic project. We expand this out, and we see here's Array Classic main.h. We'll open the .cpp here. And so here's the code for the main program, and we'll talk about this after we do the demo. But there's also another file here called numbers.txt, and if we open this, we see that its content is, I think there's 16 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 16 numbers in there. 1.2, 2.3, up to 80.9. And what we're going to do is, what the main program is going to do is it's going to read these numbers from the file into the array, into the classic array. So we're going to run this. There's going to be a slight problem that I'll illustrate here, but let's just run it right off the bat here. Here it's building the project, and it says enter array capacity. So let's put 5 for the capacity. And now it's asking for the file name. Now we want the file name to be numbers.txt. So we'll do numbers.txt, right? But now there's going to be a slight problem here. Cannot open numbers.txt. Now the reason it cannot open numbers.txt is because it does not know to look inside of this Array Classic folder to find numbers.txt. I think it's looking in this folder here, but anyway, the numbers are not there. And so in order for us to run this program successfully, we need to tell the IDE, the Sea Lion Integrated Development Environment, where to look for the file, this text file for input. And the way you do it is like this. Up here in Array Classic, if you drop this down, you'll notice that this top item is Edit Configurations, and let's click on that. And now here we have called Run Debug Configurations, and this is the Run Debug Configurations for Array Classic. And here in this item right here, the working directory, anytime you run a C or a C++ program and you try to get the input from a file, you have to tell it where the working directory is, because that's where it's going to look to see where the file is. So we have to tell it that. So we go here to this browse. Okay. And we're going to browse. Now I install, and so depending on where you installed it on your DP4DS distribution, okay, so mine is in downloads just for purposes of this illustration. And here's DP4DS distribution, so we go here. And now we want to tell it that Array Classic is that folder where the working directory is. See, look, there's numbers.txt. So let's open this. And when we open this, we see that it has filled in this working directory. It's saying that this is where to go for this is your working directory. This is where to go to look for that file. So we'll click OK. And now let's run it again. Oh, by the way, you can there's another run button down here. Enter Array Classic, and we said, enter Array Capacity, and we said 5. We'll do 5 again. And file name, we'll do numbers.txt. Actually, I think I'm going to copy this. And boom, it worked. Now let's take a look at what it did. What it did is this. First of all, we gave the capacity for the array of 5. So the array can only store 5 integers, or 5 not integers, 5 doubles, 5 reals. But the problem is there were like 16 in there. So what it did is it just took the first 5 and then it ignored, these numbers up here from the file. All right. So that's one little feature of this, and the process. And so basically what it is, and by the way, it told us how much it read. It said read here. It says read count equals 5. Right. Okay. So now let's run it again. And this time, instead of the capacity being 5, let's make it 50. File name, numbers.txt. And now what's happening? Now we have the array can hold how many values? It can hold 50 values, but there's only 16 values in the file. So what it does is if the capacity of the array is bigger than all the numbers in the file, it reads all 16 numbers in the file, and then the array, and then the rest of the array doesn't have data in it, just has garbage values. All right. So that little feature is a very clever, this is a very clever feature of our input code that allows us to do this. There can be a mismatch, and of course, if we run it here, let's just do one more run with exactly the same amount. See if we put the capacity being 16, and then we do this, then there's exactly the same amount of data in the file as the capacity of the array, and everything just fits just right. But there can be a mismatch one way or the other, and the program works no problem. Now, so that's one feature of the input and how to do that from a file in CLine. Now comes a big experiment. Now watch this. This is going to be super cool. Here is our main program, and watch this. What we're going to do is and by the way, when we did this read stream, that read stream is a function that reads from the
file into the array and takes care of that mismatch one way or the other. I had to code that up to do that. And we can take a look at the code briefly in a minute. But and then this line closes the file. And then here it says, read count is length. And so that's where this read count length, how that got printed out. And then here it says array data. And so here's the array data. And then write stream did all of this. Yeah. All right. Now watch this. Listen up, you guys. This is way interesting. We're going to uncomment these lines here. Are you with me, sports fans? And check this out. What is our cap? Here, let's run this one more time now what we're going to do is we're going to run. Oh, I had to rebuild because I changed the main program there. Did you notice that? And now let's put array of capacity of 5, right? Now, and then here, file name, and we'll put numbers.txt. But now look, let's think what's going to happen. What is our capacity going to be in this case? It's going to be 5, right? So, but what does this do? This does ARR array sub 2 times 5. So this is array sub what? Sub 10. But wait a minute. And it's array sub 10 gets 123.4. But wait a minute. The capacity of the array is only 5. But the array only goes array sub 0, array sub 1, array sub 2, array sub 3, array sub 4. Right? Anything bigger than 4 is outside the bounds of the array. So where is it going to put this 123.4? It can't put it in the array because the array is not big enough. So where is it going to put it? It's actually going to put it outside of the array in memory somewhere, and you're going to clobber that piece of memory, whatever's there, next to the array on the right side of it. Right? And then what's this line going to do? That is going to outstream to the output array sub 10. So it's going to take that 123.4 that it stored outside the bounds of the array, and it's going to output it. Now, what's going to happen? What's going to happen when we run this? What do you think? Watch this. Drum roll. Look, it did it. There's the 123.4. It actually stored that outside the bounds of the array, and then it retrieved it and output it. But now watch this. Here is something really interesting. If we run this again, this time we're going to do a capacity of 1,000. Well, all the numbers are going to fit, right? And furthermore, it stored the 123.4. Now, where did it store the 123.4? It stored it at array sub what? Array sub 2,000. So it was really far away from the array, right? And the thing of it is that if you get far enough outside the bounds of the array, the program will actually crash. Now watch this. I think let's do 10 million. 10, 0, 0, 0, 0, 0, 0. File name. Ooh, and look what happened. This time it crashed. The read count was 16. But look, it output the data, and then when it did this array 2 times, when this did array sub 20 million, process finished with exit code of 139, interrupted by signal, blah, 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 whatever. We just don't understand what that means. But the thing of it is that if you go too far outside the bounds of the array, then it will clobber not just stuff that's close to your program and your data, but stuff that is in somebody else. It's kind of like outside the sandbox. It's like the operating system builds a sandbox around your program, and if you try to violate somebody else's property rights by going into across your boundary into their boundary, then the operating system will kill it. But as long as you're kind of like inside your own what was that, 10 million? I wonder if 1 million will. Let's do 1 million. 1 0 0 0 0 0 0. File name, numbers.txt. Ah! See? It works for 1 million, no problem. But 10 million? No. And yes, so that's an experiment that we just did this experiment, and that's an experiment that you need to do for your homework assignment. All right. End of demo.
Okay, so what's going on? What happened with this demo? What's going on here? Look, when we said, so here's the code in figure 2.9. When we said array sub 2 times cap equals 123.4, what happened when we put in there a capacity of 5? When we put in there a capacity of 5, what happened is ARR looks like this. So this is sub 0, sub 1, sub 2, sub 3, sub 4, right? And there were numbers in here. I forgot what they were. Something like 1.2, 2.3, 3.4, 4.5. I don't remember if these are the exact numbers, but anyway, are you with me? When we did that. Now, when we said array sub 10 gets 123.4, what happened literally? This actually happened. What happened is, if this is 0, 1, 2, 3, 4, then where would 5 be? 5, 6, 7, 8, 9, 10, way the heck over here. 123.4. Now, when it put 123.4 over here in memory, what happened? I mean, what is in memory over there? Who knows? But there is something out there, right? You see what I mean? So you can actually write outside the bounds of the array. And then when we said C out from this location, it stuck it in there, it put it out. You can actually access area outside the bounds of the array. And in this case, when the capacity was 5 and it just went here, then it was innocuous. I mean, something was there and it clobbered something that was supposed to be there, but who knows what that was. But the thing of it is that when we made our array, like if the array were 10,000, then it's putting it out where? 20,000 away, way far away. Now you're getting into some region of memory that the operating system is going to detect. And if you get your number big enough, then you will actually clobber. Maybe maybe you'll be trying to clobber somebody else's program or some other process. Do you see what we're saying? So the thing of it is, you guys, is that this phenomenon of being able to write outside the bounds of the array is a default feature of C and C++. Okay? And what we're talking about here, it has a name. It's called buffer overflow, because these arrays are frequently used. Buffers in an operating system are frequently implemented as arrays. And this phenomenon is called buffer overflow. And the point is that C++ allows you to access data that is out of the range of range of the array. Now, and not only that, but this phenomenon of buffer overflow is how viruses, this is 90% of all viruses are possible in our exploitations of buffer overflow, of programmers who write applications that don't check for the bounds of the array, and then under certain input conditions, this writing outside here, the virus writers can know what's out there and can actually install programs and virus programs out there unbeknownst to you. In fact, I have a paper on the website, on our course website. It's buffer overflows that describes how this works. Yeah.
So is this still used today? Like this has never been fixed in programs?
Do viruses? The question is, does this happen?
Type of, like, not like
viruses, like using buffer overflow, hackers?
Using buffer overflows, like I say, 90% of all viruses are still today are plagued are as a result of this buffer overflow. Yes, it's a bad. It's a bad. I mean, it can happen. Yeah.
So basically, the hacker knows, like, puts input into the program and knows that the program is going to that location.
Yes, and no.
Then at that location, they install bad software.
Yes,
Okay.
yes. By exploiting unusual input conditions that are not properly checked, you can go outside the bounds of the array, because arrays are used all over the place. They're used for strings, they're used for all kinds, like you have some string input and the bounds don't get checked correctly. Then yes, this is how viruses work. 90% of all viruses work by being able to go out of bounds and install malicious software that way. Yeah. Yeah.
Is it like really that useful in like non-malicious manners, like to the extent that C, like the makers of C just don't allow it anymore? Like what would you use it for otherwise?
Here's the thing. In C and in C++, they did not, in the beginning, when the languages were first designed, viruses did not exist. When C was first designed, there were no viruses. Okay, so the language did not have that built in. By the way, what language has automatic bounds checking built in? Very popular language. Java. Yeah, those of you who have written in Java know that in Java, they actually check the bounds at runtime. But you understand that that happens at runtime, so that makes the program do what? Slow down, because every time you access an array, you have to check, is it in range or out of range? And so in Java, that's an out-of-bounds exception, but that slows it way down. So there's always an efficiency trade-off. But nowadays, safety is paramount. But it's not built in. It's not built into the C language. And like I say, I have a paper that describes buffer overflow, and you can download it you can look at it on our website, on the course website. But if you Google this, you'll see there's all kinds of information out there about how buffer overflows work. So here's what we're going to do. In this course, we want to construct a safe array. All right. So that's that array T, right? And so I'm going to do let's do another demo here. And what in Figure 2.10 is the code for a safe array. Now look at this Figure 2.10. It has the same. The main program looks the same, and this is array T. So I'm going to demo array T. And see what happens when we run it.
Okay, so here's our demo, and we had just done array classic. This time we're going to do array T. So you'll notice that here's our array T main.cpp. Looks very similar to the other one. There's the lines that we will comment out in a minute. And notice that there's a numbers.txt in the array T project as well. So let's see it. See, it looks very similar to the, in fact, I think they're the same numbers. Let's take a look. These are the numbers. This is the numbers file in array classic. It looks like they're the same ones, same numbers. But anyway, these are the ones we want to use. So remember, what we want to do is select array T here, and then we have to edit the configuration. And remember, we have to tell the IDE that the working directory is array T, so we browse. And my DP4DS distribution for this little demo is in my downloads directory. And so here it is. And this time, instead of doing array classic, we do array T. And there's the numbers.txt. So we click open here. And here is, so this is the working directory. So it knows where to go to get those numbers. So we'll say OK. And now this array T main is the program that we're going to be running. And first, let's just run it right off the bat here. And we'll enter the array capacity. We'll put 5, file name, numbers.txt, read count equals 5, array data 1.2, 2.3, 3.4, 5.6. Yeah? Are we good? So the capacity is 5, and it did the first 5 numbers. Now, watch this. Check this out. Now we are going to do the same thing we did before. We're going to comment these out, right? And so now what's going to happen is we're going to try to put, after we put the 5 numbers in there, we're going to try to put 123.4 at array sub 10. Now what happened the last time we did this with the unsafe array? It seemed to work okay, right? We put it outside the bounds of the array, we fetched it, and we output it the 123.4, right? But what's going to happen this time? Watch this. Enter array capacity. We'll put 5. File name, numbers.txt. Are you ready? Drum roll. This time what happened? It says what? Array T index out of bounds, index equals 10. So even though the raw array allowed us to write outside the bounds of the array, array T will not let you do it, even no matter if you just try to go a little bit outside the bounds of the array. Even if you just go one more farther than you're supposed to, it will catch that error, and it will tell you what the index was that caused the error, and it will crash the program, terminating with uncaught exception of type int. Yeah? So here's the thing, you guys. I mean, this array is safe to use because if you try to go outside the bounds of the array, it will not let you. The program will crash with an error message. And not only that, it will tell you exactly what the index value was that caused the error. And that can be a very helpful clue when you're debugging your program. And I guarantee you, practically everybody in this class is going to write some code in the future in here where you get this error message. And this is why we're using array T, the safe array, so that we can know when we go outside the bounds of the array, and we can use the information of the index value that caused that to crash. We can use that information to debug our programs.
Okay, so that's the demo. Any questions about the demo? Did I see? Okay, so now the question then is, how does this software, this safe array software work? So let's take a look at how it's structured. In figure 2.11 here, we have, the way it works is we have a superclass, a sequence, ASEQ, which stands for abstract sequence, and then we have an array T and an array P, and each one of those inherit from a sequence, ASEQ. Now, I think I asked this once before. Have you guys done C++ templates? So this, a little bit, yeah, a little shaky.
Like once or twice just to show us what it was, but we didn't really go into it.
Yeah, that's okay. That's okay. Okay, so here's the thing. We are going to use templates a lot. Okay, so I'm glad you got introduced to them. And so now this is our first example of how templates work, C++ templates work. Now, first of all, do you remember the main idea of what a template is? A C++ template? Well, it's true that when you do templates, that you have to have your HPP and your CPP files combined into just your HPP file. But that's not the purpose. Yeah. Okay. Here's the purpose here's the purpose of templates, and this is going to be a good illustration of it. All right. You know how? And let's do an example. Let's do an example with just a function. So you know, if we say void if we say void alpha, and let's say we say int I, and then we have some code, right? Now this I, is this I the actual parameter or the formal parameter? It's the formal parameter, and then if you call it, you can say alpha 5. When you call it, you can say alpha 5. And is this 5 the actual parameter or the formal parameter? It's the actual parameter. Now here's the idea of a template. The idea of a template is the formal parameter, let's do an example here from figure 2.11. In this formal parameter, T is the, quote, formal parameter, is the, quote, formal parameter. And then, do you remember what that array was? It was an array of what? What was that an array of? When it printed out the types, what was it an array of? Yeah, I don't think it was integers, because weren't there decimal points?
Doubles.
It was an array of doubles, right? So here, T would be the formal parameter, and then double is the, quote, actual parameter. You see what I'm saying?
So you don't have to specify the type.
So that's what it is. That's exactly what templates are. You don't specify the type until you, except in the actual case. So the library is built with a general type, and then you use it. When you use it, that's when you give it the parameter. Sorry, that's when you give it the type, as if the type were an actual parameter and T is the formal parameter. Do you see what we're saying here? Now, because look, here, let's go back to the code.
The type and the input going into it?
No, yeah, watch this. Watch this. Let's go back to figure 2.10. You see where it says type def, array T, angle bracket, what? Double, end angle bracket. That double is the what? That double is the what? It's like the what? The actual parameter, so that whenever you create a safe array, we don't have to have a safe array for integers and another safe array for doubles and another safe array for something else. We can just have a safe array for an arbitrary type. And then we say what the type is in the client program that uses the library.
Is this kind of like polymorphic dispatch?
No, this has nothing to do with polymorphic dispatch. Good question, but the answer is no, and the answer is no. It doesn't have anything to do with polymorphic dispatch. We'll have to take a look at the details of this next time, but I think you know. Oh, let me just say one more thing about your homework assignment. So your homework assignment is not to hand in a program, it's to hand in a PDF file. All right? And all I want you to do is install Array Classic and Array T, okay, on your from your DP4DS distribution, and do the experiment that I just did and report on it. And type it up in a word processing file or a text editor, and export as PDF or save as PDF, and hand in the PDF with just a little description, a little couple of sentences of what happened. That's all you need. You don't have to hand in a program. All right? You can email me with questions if you'd like. All right, see you on Thursday.